I'm going to do the part 2 of this question. That's B part of this question, where the current ID1 is equal to 0.12 milliampere, ID2 is equal to 0.04 milliampere. Here what we need to find is we have to find out the VID, that's input differential voltage, and also we have to find out the VS, VD1, VD2 and VD2 minus VD1. Okay, now let's see how to find it. Like in the previous question I did in the previous video, when current are equal, we say that vG2 is equal to vG1. It's only happen when currents are equal. So vG1 was 0 and it was easy to solve. But here these currents are not equal. We have ID1 0.12 and ID2 is 0.04. So we had to use an equation to derive the voltage, input differential voltage. The relationship between the current ID and the input difference voltage is given by this. ID1 is equal to I divided by 2, that is the I divided by 2, and then plus I divided by V over drive, and then times V input differential voltage divided by 2. And if we rearrange this equation in terms of input differential voltage, that comes out to be 2 times ID1 divided by I minus 1 V over drive. Okay, now we have all the values available. 2 times ID1, that is given to us in the question, that is 0.12 milliampere. Milli, and I is given in the question. We are using the 9.1 question for this one as well. In that one we have the I provided, that's 0.16 milli, and then minus 1, and then V over drive. I did in the part 1 of the question, that is I solved the V over drive for this current. Okay, and the V over drive is same for everything. So 0.12 is the V over drive. Okay, so use that one. 0.2, and you will end up getting 0.1 as the input differential voltage. Okay, that is VID. Now we are doing the B part of the question, and also we need to find out VS, VD1, VD2. Like to find out the VS, this equation is useful. I grabbed this equation because this equation I derived from the current equation. Current equation is given by half Kn prime W over L or V over drive square. So if you rearrange this one in terms of V over, you will end up getting this. Let me copy that. So V over drive is equal to square root of 2 times ID1 divided by Kn prime W over L. And why this is good is because V over drive is nothing but VGS minus V threshold. So we can also write this equation as VGS minus VT is equal to square root of 2 ID1 Kn prime W over L. And VGS is nothing but VG minus VS. Okay, VGS minus VG minus VS and minus VT is equal to this whole thing, 2 ID1 divided by Kn prime W over L. And here we are trying to solve for VS, so what we can do is we can bring the VS to the other side of the equation. So VS, that will become VG minus VT minus square root of 2 ID1 Kn prime W 2ID1 divided by Kn prime W over L. Now we have the equation, we plug in all the values. Vg is the, okay, here if you look at the question, vG1 is equal to VID. Okay, this one also vG1 is equal to VID, and this is vG1. Okay, that is 0.1 minus V threshold, that is given in this question right here, 0.4. Plug that one in, and the current we are dealing with is 0.12, so 2 times 0.12 milli divided by Kn W over L. Kn prime is given to us 0.4, W over L is 10, so 0.4 milli times 10. Okay, if we solve for Vs, we will end up getting negative 0.545 voltage. Okay, that is our Vs value. Now once we find out Vs, that is it, and then we have to find out Vd1, Vd2 and Vd2 minus Vd1. To find out the Vd1, you have to just use this equation, Vdd minus I divided by 2 times Rd. This is used based on the KVL applied here. Also you can write this one in terms of current as well. This current must be equal to this voltage minus this voltage divided by the resistor in between, and if you rearrange this one, you will get this one. So Vd1 is equal to Vdd minus I divided by 2 times Rd. Vd1 is equal to Vdd minus I divided by 2 times Rd. I divided by 2 is nothing but whatever the current flow through the drain. That is given to us already. That is given to us as 0.12 milliampere, so we don't have to do anything extra. So instead of this I divided by 2, we can just substitute 0.12 milliampere. So this is going to be, VDD is given to us in this question, that is 1 voltage. Plug that one in, and I divided by 2 is 0.12 milliampere, and then RD is also provided in this question, that is 5 kilo ohm resistance. So plug that one in and solve for this. You will end up finding the Vd1, that is to be 0.4 voltage. Okay, once you have the Vd1, now we can find the Vd2 also. Vd2 also we had to find Vd2, exact same equation, Vdd minus I divided by 2 times Rd. Vdd is same, I divided by 2, the current flowing through this one, and for this one we have a different value. Since they mentioned ID2 to be 0.04 milliampere, we have to substitute that 0.04 milli times the resistance is same, 5k. Now you will end up getting 0.8 voltage. Okay, so we have Vd1 and Vd2. Then VOD is our Vd2 minus Vd1. That's output differential voltage. And then Vd2 is 0.8, Vd1 is 0.4. So this one comes out to be 0.4 voltage. Okay, and that is it for this video. I hope you guys found this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys.